Hello friends, in this video today we are going to discuss trapezoidal math rule, Simpson's 1/3 rule and Simpson's 3/8 rule. Integration of f of x dx from a to b in this interval. Okay, so let us suppose this is the curve of y is equal to f of x, curve of this polynomial f of x. Okay, so here suppose y is equal to f of x and we need to evaluate from this this is suppose a and this is b. We did this interval and here corresponding value of x is suppose x is not here and here it is xn. Now let us divide the interval a to b in n number of sub intervals of with h. So now value of this integral is nothing but this is the area below the curve. Okay, so in order to find that, let us divide this interval from x naught to xn. Let us divide it in n sub intervals of with h. So that means x naught and next one will be x naught plus h, then next it will be x naught plus twice h and so on. So here the width of this interval is h. Okay, it's an every divisions. Okay, with it h, and let us assume that this is y naught, this is y1, this from here to this point this is y2 and this is yn, from this point to this is yn. Now in order to obtain the area of this area below the curve, we have to add the area of its section. Here we have got, and we have divided this interval such that we can consider that it is a trapezium. Okay, each section is a trapezium. Okay, so there will be definitely error some here. So as the width is h, therefore x naught will be, sorry, not x naught, xn will be here. In this case xn will be equal to x naught plus n into h. So now let us find the area of this first section from x naught to x naught plus h. So here you see, so we know the area of a trapezium is given by half into sum of the parallel sides and distance between them. So in order to find here you see the integral from a to b y dx, which is nothing but integration a to b of f of x dx. So we have to add the area of all these sections, all these trapezium, the 1 2 3, how many trapeziums are there up to this, we have to add all the areas. And remember one thing, here a is nothing but x naught and b is xn. Now let us find the area of the first trapezium, this first section. So you can see the figure here. So if you find that it is between the interval x naught and x naught plus h. So for the interval x naught and x naught plus h. So x naught and x naught plus h y dx, that's going to be equal to area of the first trapezium. The first trapezium, here you see parallel sides are y0 and y1 and distance between them is h. So therefore area must be half into sum of the parallel sides, that means y0 plus y1 into h. And for the next interval from x0 plus h to x0 plus twice h. So that means we need to find the area of the next trapezium. Area of the next trapezium, here you see 0 to say x0 plus h to x0 plus twice h y dx. So area of the next trapezium will be, so in the next trapezium parallel sides are y1 and y2 and with is same h. Okay, so here y1 plus y2 into h. Similarly we can find the area of the n trapezium, that is from x0 plus n minus 1 into h to x0 plus n h y dx, that will be equal to 1 by 2 y n minus 1 plus y n into h. Now in order to get the value of this integral from a to b f of x dx, that means x0 to xn y dx, we have to add all those areas that we have got here. We have to add this one up to this area. Okay, so we have to add all those. So if we add all those, then what we will get? Half of y0 plus y1 into h plus half of y1 plus y2 into h plus and so on, and at the end half yn minus 1 plus yn into h. So here we can take half and h common, then what we will get? y0 plus y1 plus y1 plus y2, then y2 plus y3, then y3 plus so on up to yn minus 1 plus yn minus 1 plus yn. We will get this. So here if you observe this pattern, here you see excluding y0 and yn, all terms are all the terms are appearing twice. Okay, y1 twice, then y2 twice. So that's why we can write as half into h into y0 plus 2 into y1 plus y2 plus y3 plus dot 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 up to yn minus 1 plus yn bracket close, and simply we can write y0 plus 2 into summation starting from 1 to n minus 1 yi, you can write it this way, plus yn. So this is our trapezoidal rule. So this is the trapezoidal rule. Now Simpson's 1/3 rule. So as in the previous case we have evaluated I is equal to a to b integration of f of x dx, where y is equal to f of x. This is a polynomial and its curve is given by this. Suppose this is the curve of this polynomial y equal to f of x, and we need to find its value, and that means we need to find the area below this curve from a to b, this interval. So again we have made n intervals, n number of intervals of with h, such that in this case a is equal to x naught and b is equal to xn, and in this case width is h. Okay, so hope you have understood this. So now you see, then by Newton's backward difference formula, so by Newton's backward, sorry, not backward, forward difference formula, so this is the Newton's forward formula that we have got. We have already discussed in the previous video, so I will provide the link in the description box. Please watch that video. So where u represents, u is equal to nothing but x minus x naught by h, which implies x is equal to x naught plus u into h. Okay, so this is the meaning of u in this case. Now in order to get the area below this curve, so what we are going to do in this case, we are going to integrate this on both sides. So on the left hand side, integration y dx from x naught to x naught plus nh, and on the right hand side you see, so here we have y naught del y naught square, so this is y naught, here it is y1 y2 and so on up to yn. So we have to integrate from 0 to n, so 0 to n, integrating on the right hand side here, y naught plus u into u minus 1 by factorial 2 del square y naught plus u into u minus 1 into u minus 2 by factorial 3 into del cube y naught, and so on. And here it will be h du, because here you see, as I have already mentioned here, x is equal to x naught u plus h, and from that relation we get dx is equal to h du. Now that's why we have got here h du. So hope you have understood this. Now after integration, what we will get, if we integrate and simplify, so I'm not gonna show the integration part, just remember the result here in this case. So if you integrate and replace u by n, u by n, and after integration and simplification, so our result will be x naught. So after integration and simplification we have got this result. So here you can see, so this is the result we have got, and this is suppose equation number 1. But in order to obtain the Simpson's 1/3 rule, here we have to assume this width h is multiple of 2. Instead of h we will consider this is twice h. So the next limit will be here x naught plus twice h in this case. So that means we have to consider this way. So this is the curve of suppose f of x, and we have to consider this one x naught, this is the x-axis, x naught, then x naught plus 2h and x naught plus 4h and so on. Then first let us find the value, putting n is equal to 2 from the interval x naught to x naught plus 2h, if you put n equal to 2 here, you see in this case if you put 2 here, n equal to 2 in this equation 1, so from this term, from del cube y naught 0, here if you put 2 here, then this term will be 0. So not only this term, after this term, all the terms after this term will be equal to 0. So we will get only these 3 terms. Now let us put 2 here, and then what we will get, 2h y naught plus del y naught plus 1 by 6 del square y naught. This is the result of integration y dx from x naught to x naught plus 2h. So what will be the result of the next interval? So before that, let me simplify this. Now you know from the Newton's forward difference rule, difference table that we have discussed in the last video, that del y naught we have got y1 minus y naught, and del square y naught was y2 minus twice y1 plus y naught. If you put those values here and if you simplify this, then you will get this result. Then you will get h by 3 y naught plus 4 y1 plus y2. Now here you see, carefully observe the pattern. So what we have got, the integral in the first interval from x naught to x naught plus 2h, we have got this value of this is equal to h by 3 y naught plus 4 y1 plus y2. Now observe the pattern only. We can find the value of this, we can find the area of this section also. So just observe the pattern. So next will be x naught plus twice h to x naught plus 4h y dx. Here it will be equal to h by 3 again, h by 3 here you see. Now look at this. When we have started from x naught, here we have got y1. Now we, here you see, this is x naught plus 2h. When you have x naught plus 2h, then you have to start it from y2. Here this y naught will be y2, and this y1 will be 4, this y1 will be for y3, and this y2 will be y4. And similarly the next section, area of the next section, that is from x naught to 4h to x naught plus 4h to x naught plus 6h y dx. This will be h by 3. Now it will be y3, sorry, not y3, here in this case it will be y4 plus 4 y5 plus y to the y6. So observe the pattern, you can remember easily these things. Okay, so at the end, the area of the end interval, what we will get, that means from x naught plus n minus 1 into h to x naught plus nh, that means you can say xn y dx. So this one will be equal to h by 3 y, here I have done a mistake here, it should not be n minus 1, it should be n minus 2. Okay, n minus 2, as we are taking the interval as multiple of 2, so here it will be n minus 2. So here Now yn minus 2 plus 4yn minus 1, then plus yn. So this one we will get. So if you add all these results from this interval to this, if you add all those, so summing up this or adding, so you will get this value from x naught to xn y dx, or it is equal to from a to b integration f of x dx. If you add those, then you will get h by 3, then y naught plus 4. So here you see, if you observe the patterns here, so we have here 4y1, in this case 4y1, 4y3, then 4y5, then 4yn minus 1. So here we have got y odd, that means y1, y3, y5, these are occurring 4 times. That means 4 into y1, 4 into y3, that's a 4 is taken common here. And here you see, if you observe the values of y even, so here you see, in this case, so let me tell you here you see, this is y2, and here also y2, this is y4, here also y4. So y even, that means y2, y4, y5, these are, sorry, not y5, y6, y8, these are appearing twice. So that's why we can write 2 into y2 plus y4 plus y6 and so on up to yn minus 2, up to yn minus 2. Then plus only these two terms here you can see, only xn and yn and y naught, this one y naught and yn, each of them appearing once only. So here it is yn. So this is the final result. So this is the Simpson's 1/3 rule. Again, from the same equation number 1 that we have used to derive the Simpson's 1/3 rule, we can derive 3/8 rule of Simpson using the same equation number 1 that we have already used. So this was the equation number 1 that we used to derive Simpson's 1/3 rule. Now same formula, we will use this same formula to derive Simpson's 3/8 rule. So how to use that? Now here you see, in the previous case, Simpson's 1/3 rule, suppose this was the curve, suppose f of x, and this is x-axis. Here we have considered x naught and x naught plus 2h and x naught plus 4h and so on. So we have considered the width is multiple of 2 in the 1/3 rule of Simpson. So here in this case we are going to consider that this width is multiple of 3. So we will consider thrice h. Okay, so x naught, then next will be x naught plus thrice h, then next will be x naught plus 6h and so on. So hope you have understood this. So that is the only difference. And here, to obtain the 3/8 rule, we will put n is equal to 3 in equation number 1. So then what you will get? So for the interval x naught to x naught plus 3h y dx, integration y dx, that's going to be equal to 3h y naught plus 3/2 del y naught plus 3/4 del square y naught plus 1 by 8 del cube y naught, then remaining terms will be 0. So here you see we have got this. Now we can, sorry, not this one, we can replace del y naught by y1 minus y naught and del square y naught y2 minus 2y1 plus y naught from the difference table, forward difference table, and similarly this can be replaced by y3 minus thrice y2 plus 3y1 minus y naught. And if you replace those values by this value, then simplifying, after simplification, we will get 3h by 8 into y naught plus 3y1 plus 3y2 plus y3. So we will get this. So for the next interval, so what will be the result of the next interval? That means from x naught plus thrice h to x naught plus 6h, in that interval we will get thrice h by 8, this is same, and here you see it is starting from y naught and ending at 3. Now observe the pattern. Then next term will be starting from y3, then thrice y4 plus thrice y5 plus thrice, not thrice, then y6. So here you see this is y naught, y1, y2, y3, then again y3, y4, here it is y5 and y6. So similarly next interval will be started from y6, then 3y 7 plus 3y8, then y9. So that's going to be the value for the next interval, that is x naught plus 6h to x naught plus 9h, and so on. So if we continue, this is y dx here, if we continue this way, then the final interval value for the final interval, that is x naught plus n minus 3 into h up to x naught plus nh, that's going to be equal to 3h by 8 y n minus 3 plus 3 y n minus 2 plus 3 y n minus 1 plus y n. So I forgot to give here y dx. Okay, so this is the area of the final interval. Okay, so that means area between the final interval. Now if you sum up those values of this, if you add this area and up to this, then what will you get adding all these areas? Adding all these areas. Now observe the pattern again. Here you see, so y naught will appear once only, then y3 appearing twice, then y6, then okay, this term also will appear twice. That means all those terms y, that is multiple of 3 into something, suppose 3i, these are appearing twice. Okay, and y naught and yn will appear once. And here the middle terms you can see, this is thrice y, and thrice y1, thrice y2, thrice y4, thrice y5. Okay, so if you observe the pattern clearly, we can write that integration from x naught to xn is integration of y dx from x naught to xn, that's going to be equal to 3 by h 3h by 8 y naught plus yn. These two terms are appearing once, and here you see y1, y2, y4, y5. That means if you ignore the multiples of 3 y, if you ignore those terms y I into 3 from then actually not ignoring, so these terms, so let me show you. Here you see y naught, y1, y2, y3, y4, y5, y6, y7. If you sum up all those areas above we have found, if you add all those, then you will observe those terms y1, y2, y4, y5 will appear thrice, and these terms y3, y6, then y9, which are multiple of 3, those are appearing. Actually value of y9 is not multiple of 3, I am saying in the sense this suffix is multiple of 3. Okay, so only those terms are appearing twice. So here, so let me clear this page. Okay, so here we can write 2 into y3 plus y6 plus y9 plus dot 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 up to y n minus 3, then plus, and 3 into write the terms which are remaining, which are appearing twice. Those are y1 plus y2, then again y3 is here, so that's why y4 plus y5, then y6 is here, then y7 plus y8, and so on up to y n minus 1 plus y n minus 1. So this is the final result. So this is nothing but Simpson's 3 by 8 rule. And remember one more important thing. So if you need to find evaluate such integrals for n equal to even number, then we will use 1 by 3 rule, and for odd number, not only odd, for n equal to suppose a number multiple of 3 into something, then in this case we will use this 3 by 8 rule. So hope you have understood this. So if you think this video is helpful, please share the videos and hit the thumbs up button.